Hey everybody, this is Larry. It is January 25th of the year 2023. Those of you who are following, you might know that I've been doing a daily extra problem because I don't know, I paid for premium, so let's just get one of those problems in because the daily problems a lot of the times I've already done it before. So this is kind of what I call the bonus question. So let's get to it. Let's find one that I haven't done yet. Let's see, and then let RNG pick one for me. Let's go. And today's problem is 2431. Maximize total tastiness of purchased fruits. This is like a tongue twister. Try saying it like 5 times fast, right? Maximize total tastiness of purchased fruits. All right, but it's a medium problem. Apparently a lot of people like it, and let's take a look. So, and hope everyone is having a good week. Hump day. I'm kind of really, I've been really tired lately. I've been on a 6-day workout routine, and really it's been just destroying my body. So I've just been really tired. I need to kind of scale it down a little bit from time to time. I know a couple of people asked me about my workout in my comments. That's why I'm kind of talking about it. But you can also come to Discord where, if you're curious, then yeah, I think I kind of talk about my workout routine there too. Anyway, today's problem is, let's actually read the problem. Hope everyone's doing all right. Hope everyone's just having a good week. All right, let's see. So you have two negative numbers, integer arrays, not numbers. Wow, I can't read. Price and tastiness, both arrays have the same length n, so they're basically like a sipped array maybe. Okay, so for every integer I, so we want to sip them together, and you want to purchase some fruit such that the total tastiness is maximized and the total price does not exceed max amount. So that means that we want to kind of, I was going to say up to here, this seems like a very standard knapsack problem. And I'll kind of type it up so you can Google it, if you will. Knapsack problem. And this is, this is relatively speaking NP or in NP. I always forget whether it's an NP complete or not. I'm too. It's been a while. I don't look it up, so maybe I should. But with a pseudo polynomial solution, which is done by DP in general. Okay, so let me finish reading because then I think I saw something like additionally you can use a coupon to purchase a fruit for half its price. Round down. Okay. And you can use at most max coupons. So there's a variable that's max coupons. Return the maximum total tastiness that can be purchased. So max coupon does make it interesting. Just if nothing else, I don't know the immediate literature, right? Some of the times you're gonna see that some of the solution is just literature, and what I mean by that is that, some people may say it as a textbook problem, and that means just that these books literally are taught in textbooks and in intro classes. Not to say that it makes it easy. It's just that it makes it like a lot of people know them just because they've seen them before, literally from textbooks. But you still have to go through the process of learning and really understanding to solve these things, right? Okay, so you could solve in fruit once. I wanted to be honest, I wanted to kind of look into this without looking at the constraints, so I could kind of maybe figure out the difficulty a little bit, but I did kind of not lie, but I did cheat by looking at the constraints. So the constraints kind of give it away a little bit, the game. I also hate that this is kind of a medium. That's why I don't really like getting a hint on the difficulty. So I don't think this is a medium per se, though I can understand it. It's just that I think it is not an easy problem, but just because the answer is going to be brute force in some way. But okay, so there are a couple of observations, or at least properties that I think we can kind of that I can make an observation on, which is that when we use a coupon, and maybe I'm just taking notes because and I don't know the answer at this current time of me talking right now. I'm not definitive of an answer, though I do have an idea. But when we use a coupon, we want to use it on the most expensive stuff. Makes sense so far, right? So that means that is that true actually? I don't know. Well, if we actually buy something, then we would use it have price, but you don't have to use it on the end expensive stuff of the stuff that we purchase, I guess. I guess then in that case, it just becomes okay. I mean, I think I wanted this to be slightly more beautiful, maybe, but it seems like it is just actually pretty standard in a way. The max coupon just becomes a dimension because it's just so small, to be honest. So what we already talked about a little bit with the pseudo polynomial dynamic programming, and because of that, we can actually just create an extra dimension about how many coupons we've used, because there's only 5, so that means that there are only 6 states. I don't have 6 states, right, from 0 to 5 inclusive. So in that case, roughly speaking, you're going to do a pseudo polynomial DP on the max amount, which is going to be 1,000, and then you do it for each 100 items times 5. So that's going to be good enough. I am going to this is going to be 500,000, so it is going to be a little bit too sketch to do it top down, at least on Leetcode. But also it's a good practice for me to do it bottoms up, though it is a little bit harder to explain. But the states are pretty straightforward, I think, which is that, let's say we have DP sub amount, and this is a function. I used the rate notation. Maybe I could use a function notation. DP, or maybe you can just say f of for function amount, and or index, and then coupons used, right? Whatever used, I can't spell, right? So what is this function going to be equal to, right? This function is basically going to be a max, of course, of a max of whether we use the amount or we buy this item on the index, right? So we minus something like price of index, so index plus 1, because we're done with that one. Used is still the same, plus tastiness of index, or we do the same thing, but we used a coupon, right? So this is going to be used plus 1. Obviously, maybe you do an if statement to make sure that used is less than max coupons or something like that, or maybe you could kind of count down instead. Either way, right? So it's something like this, but now it is price over 2, right? Divided by 2. Maybe in the pseudocode it's not Python, so I just do this. And then the last one is just not buying it, right? So you still have the same money, index plus 1, used, and then that's it, right? So that's pretty much it. That's going to be your dynamic programming function. And honestly, if we implemented tops down, in Python and probably in a lot of languages, it'll be roughly the same as this. Like I said, you have to do some index and base case, but I think in both cases, it's you have to make sure that, for example, you could afford it and etc. Right? And then the space analysis is going to be amount could go from 0 to 1,000, hence bringing it pseudo polynomial. Right? Index is 0 to n, and used is going to be 0 to 5 because that's the max coupon. So in total, with n being n is equal to 100, so that's just going to be 5,000 items max. But you can also write it as big O notation is O of, I don't know, A times n times maybe C for coupon or something like this, right? And then each of these will also be a space, because we only do 3 operations ish. Not actually 3, but you know what I mean. Three things or constant number of things, right? So that's basically the idea. Yeah, and then now we're going to convert it to using bottoms up. And there's actually a space optimizations that you can do depending on how you want to write it. You can actually do 2 different types of space optimization depending on which one you like. You can actually space optimize on, is that true? Actually, I don't know if that's true. Maybe it's true, but there is definitely one that I could prove, so I'm going to do that one. And maybe it's not true. Maybe what I said earlier is not true. So I don't know. But there's definitely at least a space optimization, which we're going to show. because you know I have a crew of people here telling me the answer. No, yeah. So basically, we have a previous is equal to say 0 is times a max amount plus 1, and this is not quite ready yet. Hang on, but this is the so previous of ij is equal to max that we can buy with I dollars or whatever it is. Let's just say I dollars and J coupons left, or J coupons used. Maybe that's a little bit better. So okay, so I actually messed this up a little bit. So now the J is on the inside. So actually we want this to be max coupons, maybe. Yeah, plus 1. Right, something like that. And then yeah, and this is for the previous row. We also have to set up some base case. No, we don't, do we? Huh? No, I guess not. Yeah, no, we do not. But okay, yeah, doing a bottoms up is always a little bit tricky for me, so definitely excuse me. But yeah, for then now we just go for let's just say so now we want to do the index for whatever index and range of n. Did I say? Did I couldn't. Oops, just put it on top, I suppose. N is equal to length of price, right? Yeah. And then now we just go for and there's actually an additional space optimization trick that I'm not going to use here. But for those of you who don't know the additional space optimization trick, pause the video, maybe like do in your head, and then maybe I'll talk about it in like after I type this out. I'll talk about it, and then you know you can maybe see if it makes sense. But yeah, and then now previous current is equal to say something like this, but I always feel like I write it a little bit differently. All right, so then yeah, so then now for amount in range of max amount for coupon in, well, let me just say used in range of max coupons, also plus 1. I messed up there. What do we do, right? Well, current of amount and used is just equal to and this is basically we just write this formula, but like I said, now we have to actually implement it. Either previous amount used, because that's basically this thing except for index -1, but whatever. Right, so we set it that way, and then yeah, let's see if amount is greater than or equal to price of index, right? Just creating more space for me to, because on the bottom is always a little bit awkward. And then here, how does that always? All right, is then we see if we can, yeah, right. This is basically the first line, which is, you know, so previous of amount minus price index and then used plus tastiness of index, right? And then at the, let me write this and then previous is equal to current, but yeah. And then what I want is what do I want? Yeah, I think max amount, max coupon. I think this should be good. I mean, this isn't sufficient, but I wanted to run my code just to make sure I don't have any typos. That's why I kind of focused on this part first. I know that's not gonna be the right answer probabilistically, unless I get unlucky and get the right answer and think I'm done. But no, right? And then so we already did this one and we already did this one, so we have to do the coupons one. So if amount is those two, round down, and maybe I do it the other way first, which is use this greater than 0, because that's a cheaper track. It's already minimally cheaper, but and then -1. Okay, that's maybe good, but maybe I'm price. Isn't that prices? I don't know. I never know how to say stuff anymore. Okay, so that looks good, at least for these cases. Did I miss anything? I don't know. Let's give it a quick submit. Hey, cool. A little bit slower. Did I miss maybe there's something that it could be greedy on that makes it cheaper? I don't know, because I already did the space optimization. So there is a slight optimization that you could do as well. Yeah, and you have to figure out how to prove it. But if you do these for loops backwards, you don't need a second thing. So that's your hint. That's your thing right there. But that's it used to matter a little bit more when I was younger, because memory is like really expensive, but I think nowadays it doesn't really matter. It's just like another thingy, right? But may save your life one day. I mean, I don't know. I don't know about that, maybe, but still. I am just curious why, like, I don't usually care about slowness, but this is kind of a little bit. I wonder if there's another optimization I could have done. I mean, I definitely like here we definitely do math on things that are not necessary, and maybe if we do it tops down, maybe it would have been okay. And there is some luck there in that you don't know the inputs, and what I mean by that is that maybe a lot of these states are not reachable, but for here we made we check for them anyway. Where in top down, if there are a lot of states that are not reachable, then you just don't do work on those states, which in theory, like, can make it, like, if half the states are not reachable, then you're twice as fast, right? But these things, it's always hard to tell a priori whether that's the case. So I don't really feel that bad about it. Though I guess pseudo, I don't know. I think that still depends on the inputs. I guess with only 100 ends, I don't know, because yeah, I mean. It still should be enough to hit everything after, like, 10 numbers. So I don't know. But yeah, we already did the complexity, so I don't have anything more. Definitely, if you want to read more about it here, it is just the vanilla pseudo polynomial DP, except for that I added max coupons to it. So so it's not so bad. Yeah. Anyway, that's all I have for this one. Let me know what you think. I'm going to do the regular daily problem afterwards at some point. It's in like 20 minutes. But yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.